Let's write the integral. We want the integral from -1 to 3 of 4 minus x squared dx, and we compute that by finding the limit as n approaches infinity of the summation as k goes from 1 to n of the product of f evaluated at x sub k asterisk, that's our sample point, times delta x. Before we proceed, let's get a visual of what this area is going to look like. It's going to go from -1 to 3. The definition is between the curve and the x-axis. So above the x-axis, from -1 to 2, and below the x-axis, from 2 to 3. We will get the net area. Let's begin by finding the delta x. That's b minus a divided by n. b is the end point, which would be 3, minus a is our beginning point, which is -1, and we divide that by n. So 3 minus -1, 4, divided by n. Now, we need to get a representation for the sample points, otherwise denoted as x sub k asterisk. I'll start with x sub naught equals -1. That's our starting point. X sub 1 would be -1 plus 1 delta x, which we just computed as 4 over n. If we did x sub 2, that would be -1 plus 2 of our width times 4 over n. X sub 3 would be -1 plus 3 times our width of 4 over n. Seen a pattern? Yes. That looks like x sub k could be -1 plus k times 4 over n. Our sample point representation, x sub k asterisk, is -1 plus 4k divided by n. Let's go back to the limit notation. We got the limit as n approaches infinity of the summation as k goes from 1 to n of f of our sample point, -1 plus 4k divided by n times the delta x, which is 4 over n. Let's simplify some things. We're going to move the delta x, which is the 4 over n, to the left of the limit for now. We'll still have the limit as n goes to infinity of the summation as k goes from 1 to n. Let's put that function notation in here. 4 minus x squared. For the x, we'll put in the sample point, which is -1, plus 4k divided by n. Let's multiply out that binomial term. The 4 over n, the limit as n approaches infinity of the summation as k goes from 1 to n stays the same. Then we'll have 4 minus, multiplying the binomial, you get a quadratic, 1 minus 8k divided by n plus the 4k over n squared be 16k squared divided by n squared. Let's do the subtraction in the brackets. 4 over n, the limit as n approaches infinity of the summation as k goes from 1 to n 4 minus 1 is 3. Then distribute that negative to the remaining terms. That'll give plus 8k over n minus 16k squared over n squared. Now let's distribute that summation notation throughout, and we will have the limit as n approaches infinity of 4 over n times the summation k equals 1 to n of 3 plus 4 over n, the summation as k goes from 1 to n of 8k over n minus 4 over n, the summation as k goes from 1 to n of 16k squared divided by n squared. Continuing, we'll have the limit as n approaches infinity. 4 over n stays outside of the summation symbol, and we have the summation as k goes from 1 to n of 3. 3 is a constant. Plus, let's multiply the 8 and the 4 together, so you have 32, divided by, there was an n in the denominator, 4 over n, and an n in the denominator for 8k over n, so we can have n squared. Then the summation, as k goes from 1 to n of k. Continuing, minus, let's multiply the 4 and 16, that'll give you 64, and we'll divide that by the total of the n cubed times summation as k goes from 1 to n of k squared. We have common summation forms for k and for k squared. Let's put those forms and replace the summation notation. The limit as n approaches infinity, 4 over n, and then the summation as k goes from 1 to n of any constant is just that constant times n, plus the 32 over n squared, and then for the summation as k goes from 1 to n of k, we will replace that with n times n plus 1 divided by 2 minus 64 over n cubed, and for the summation of k goes from 1 to n of k squared, we'll replace that with n times n plus 1 times 2n plus 1 divided by 6. We can simplify some things. The limit as n goes to infinity of 4 over n times 3n, the n's cancel, that's 12. Continuing, for the next set of terms, 32 over n squared times n plus 1 over 2. We can simplify the n's. 32 over 2, that reduces to 16. So now we have 16 times n plus 1 over 1n. Continuing. 64 divided by 6, that reduces to 32 thirds. Then one of the n's in the numerator can cancel one of the n's in the n cubed of the denominator. Then we'd have n plus 1 times 2n plus 1. And for the n squared, let's just write it as a product of two n's. Continue to simplify. The limit as n goes to infinity. 12 plus 16, we can do term by term division for n plus 1 divided by n. That would be 1 plus 1 over n minus 32 thirds. Let's do term by term division again. N plus 1 divided by n, we can write that as 1 plus 1 over n. And 2n plus 1 divided by n, term by term division, that'll give you 2 plus 1 over n. We are ready to take the limit as n approaches infinity of 12 plus 16 times the quantity 1 plus 1 over n minus 32 thirds times 1 plus 1 over n times 2 plus 1 over n. As n approaches infinity, the 12 that's a constant stays put. As n approaches infinity, the 1 over n goes to 0, so now you just have 16 times 1, minus we have the 32 thirds. As n goes to infinity, the 1 over n goes to 0, so you have a factor of 1 remaining. And as n goes to infinity, the factor 1 over n becomes 1, so we only have 2 remaining. Let's perform this arithmetic. You got 12 plus 16 minus 32 times 2, that's 64 thirds. 12 plus 16, that's 28 minus 64 thirds. We'll get a common denominator of 3 and write 28 as 84 thirds minus 64 thirds. That difference gives us the integral from -1 to 3 of 4 minus x squared dx. That is equal to 20 thirds units squared.